In this video, we are going to learn the laws of exponents, also called rules or properties of exponents. Feel free to click the link to my intro video about exponents in the description box if you are not confident with the basics of exponents. Let's start with a quick recap of what exponents are. We can write repeated multiplication like a times a times a more efficiently with the exponential notation a to the third power or a cubed. When we have the product of two a's, we can write a to the second power or a squared. And when we have just an a, we can write a to the first power. In other words, anything raised to the first power is itself. This is very important. I highly recommend memorizing this. What about a number raised to the 0th power? A to the 0th power is 1. This is also very important, so I highly recommend memorizing this. But be careful, a to the 0th power is not defined when a is 0. We call this the law of the zero exponent or something similar. Up until now, we have been looking at positive exponents and the 0 as an exponent. But what about negative exponents? A raised to the power of -1. This looks weird. How can we imagine a number multiplied by itself -1 times? Unfortunately, we can't. We can just memorize the rule for this, which says that a to the -nth power equals 1 divided by a to the nth power. In other words, any expression with a negative exponent is just 1 over the same expression with the same positive exponent. We call this the law of the negative exponent or something like that. So when we go back to our example, a to the -1, this is 1 over a raised to the first power. Remember what we learned before? A to the first power is a. A to the -2nd power is 1 over a raised to the second power. A to the -3rd power is 1 over a raised to the third power. For the sake of completeness, I have to say that this and the following rules are only defined for non-zero numbers. In other words, they work only when a is not 0. Let's look at the law for exponents, which tells us how we can take a number raised to a power and then raise that to a power. We see a to the power of m in parentheses, which is then raised to a power of n. The exponent rule for this kind of problem tells us that we can simplify that by keeping the base and multiplying the exponents together. So a raised to the power of m, which is then raised again to the power of n, is equivalent to a raised to the power of m times n. Let's say we have, for example, a squared raised to the power of 3. The power of power rule tells us to multiply the exponents together. So we get a raised to the power of 2 times 3, which is a raised to the power of 6. So when we have a number raised to a power, and that's all raised to another power, just multiply the two exponents together to simplify it. Let's look at the law of fractional exponents. A to the power of m over n is the same as the nth root of a to the power of m. So when we have, for example, a to the power of 1 over 2. As we know from the law of fractional exponents, this is the same as the second root of a to the power of 1. The second root is just the normal square root. And a to the power of 1 is a. So we get the square root of a. You saw in this lesson we used this rule twice to solve the problem, which means it's very important to memorize. Dividing by 0 is not defined. So this works only when n is a non-zero number. I will show you more examples of this law after the next video about an introduction to square roots. Let's look at the exponent rules, which tells us how to multiply and divide exponents when they have the same base. Let's first look at multiplication. A raised to the power of m times a raised to the power of n is equal to a raised to the power of m plus n. In other words, the base a with the exponent m multiplied with the same base a with the exponent n is the same as the base a with the exponent m plus n. When multiplying exponents with the same base, we keep the same base and add the exponents together. Similar to that, when we divide exponents with the same base, we keep the base and subtract the exponents. A raised to the power of m divided by a raised to the power of n is the same as a raised to the power of m minus n. Be careful, these last two rules for multiplication and division only work when the bases are the same. They do not work when the bases are different. Let's do an example for each of these laws. 2 to the second times 2 to the third. The base of both expressions are the same, and there is a multiplication between the two expressions, so we can use the law of multiplication for exponents. Now, our law tells us that this is equal to 2 to the power of 2 plus 3, or 2 to the fifth power. In other words, the law tells us to keep the base, which is 2, and add the exponents, which are 2 and 3. But let's see if this is really true. Two to the second we can write as 2 times 2. And 2 to the third we can write as 2 times 2 times 2. Because exponents have priority over multiplication in the order of operations, we have to put parentheses. Now, in multiplication, the order of the operations doesn't matter. So we can remove the parentheses and we get 2 multiplied by itself 1, 2, 3, 4, 5 times, which we can write as 2 to the 5th. Let's do an example where we divide expressions with the same base. 4 to the 5th power divided by 4 to the 3rd power. Our law says to keep the base, which in our example is 4, and subtract the exponent from the bottom from the exponent from the top. So in our example, we subtract 3 from 5, which is 2. And we get 4 to the second, which is 16. We can check if this is true by writing our problem differently. 4 to the 5th is the same as 4 times 4 times 4 times 4 times 4. And 4 to the 3rd is 4 times 4 times 4. After cancelling 3 of the 4s, we get 4 times 4 over 1, which is 16 over 1, which is 16. Again, before you use these last two multiplication and division laws for exponents, make sure that the bases are the same. Let's look at the power of the product law and the power of the quotient law. Make sure that b is not 0. The power of the product law is the product a times b raised to the power of m, which says that it's equal to a raised to m times b raised to m. In other words, you can distribute the exponents to each factor. And the power of the quotient law says that the quotient a divided by b raised to the power of m is the same as a raised to the power of m divided by b raised to the power of m. In other words, you can distribute the exponent to the dividend and to the divisor. Compared to the multiplication and division laws before, here the bases are different. The exponents are the same. Let's do an example for each of these last two laws. How can we write the product of 2 times 3 raised to the second power? with the power of the product law. The law says we can distribute the exponent to each factor. So we get 2 squared times 3 squared. Two squared is 4 and 3 squared is 9. And 4 times 9 is 36. Let's check if we would get the same if we do not use the power of the product law. Two times 3 is 6. And 6 squared is 36. In this specific case, it looks easier to solve the problem without the power of the product law. But when we are dealing with more complex problems and with variables, the power of the product law is a big help. Let's look at the power of the quotient law. How can we rewrite 3 over 5 squared? The law says we can distribute the exponent to the dividend and divisor. So we get 3 squared and 5 squared, which gives us 9 over 25. Let's check if we would get the same if we do not use the power of quotient law. Three over 5 times 3 over 5 we can write as 3 times 3 over 5 times 5, which is 9 over 25. Let's do a quick recap. Any number raised to the power of 1 is a number itself. Any non-zero number raised to the power of 0 is 1. Any non-zero number with a negative exponent is just a 1 over the same expression with the same positive exponent. Any non-zero number raised to a power, which is then raised again to a power, is the same as keeping the base and raising it to the product of the two powers. Any non-zero number raised to m over n is the same as the nth root of a to the power of m. The denominator n must also be a non-zero number because dividing by 0 is not defined. In other words, impossible. Multiplying any non-zero bases together is the same as keeping the base and adding the exponents. Dividing any non-zero bases together is the same as keeping the base and subtracting the exponents. When you have a product of non-zero numbers, you can distribute the exponent to each factor. And when you have a quotient with non-zero numbers, you can distribute its exponent to both the dividend and the divisor. I want to add two important things at the end of this video. First, I will make a video after the next video with a lot more examples and also examples about how these laws also work in reverse. Second, I highly recommend you start memorizing these laws, so it's much easier to follow the upcoming video with the examples. Apart from that, these laws are the absolute basics and required knowledge in math. By the way, feel free to check out my next video about the basics of square roots. Like I mentioned, after the intro video to square roots, I will make a video with a lot of mixed examples to these laws of exponents. If you have any questions, feel free to ask me in the comments. This video is what I did for you. If you want to do something for me, hit the bell button, share and subscribe. Thanks for watching and happy learning, everyone.